right, welcome to the lecture video for section 2.2, where we're going to talk about more graphs and displays. In the previous section, we discussed graphing quantitative or numerical data as a frequency histogram. A stem and leaf plot is another type of graph that you should have met in a previous course. I'm not going to go over constructing them because A, you should have seen it before, and B, you don't run into a lot of them. The ones we're going to look at today have to do with graphing qualitative data sets. Now, what is a qualitative data set? It's one in which the data consists of attributes, labels, or non-numerical items. If you look down here at this example, I've got a chart here of type of degrees and then the number of them. This is what I mean by non-numerical data. We have categories. If you think back to the frequency distribution table, we had classes and we had numbers. Okay, so this is qualitative data. The first type of graph we're going to look at is a pie chart. It presents the qualitative data as a percentage of a whole. So it's really good for comparing the relative sizes of each category. It's a circle. We're going to divide it into the sections. And again, the size of those sections has to be proportional to its percentage of the whole thing. So we're going to look at example 4, which is in your book. I did go and update the data for the most recent I could find, which was 2018. So the number of earned degrees conferred, and these are in thousands, in 2018 are shown in the table. Keep in mind that if I say the number is 1,011 thousands, I'm going to put 3 additional zeros on the end of it, and really it represents just over 1 million associate's degrees, okay? So make sure you pay close attention to the units put on this column. All right, so the steps in making a pie chart are: number 1, you find the relative frequency for each type of degree. Now, we've done this previously, so here is where we start to see that information become useful. I would begin first by totaling up the frequency column, and I'm going to continue to use the notation that I want you to get comfortable with. The Greek letter sigma means I'm going to add up this frequency column, and if you add all these numbers together, I believe you get 3,996. So to calculate the relative frequency, remember the formula is take the frequency of that particular category and divide it by n, which is this total number of frequencies. So I'm going to take 1,011 divided by 3,996. It's going to be a messy sort of decimal, so I'm just going to round it off to 2 decimal places, and it turns out to be about 0.25. I'm going to continue doing the same thing all the way down the column. So you can see that I've finished calculating my relative frequencies. Remember that these are the decimal version of a percentage. I could take 0.25, multiply it by 100, and find out that this represents 25% of the data. So if I total up these decimal points, so now I'm going to indicate I'm going to add up, sum the F divided by n column, the relative frequencies, I get 1.01. Now it should be perfectly equal to 1 because 1 represents 100%, but because I did round these numbers, it does introduce a little bit of an error. It's totally fine, just make sure that your number is something close to 1. Step 2 says we're going to multiply our relative frequencies, these numbers, by 360, the total degrees in a circle, to find the central angle, which represents the size for each type of degree. So to find the corresponding angle, you take your relative frequency and you multiply it times the number of degrees in a circle. And 1/4 of 360 is 90. So the associate's degree should be represented by a right angle and 90-degree angle in this circle. I continue doing this all the way down. I've finished multiplying all my relative frequencies by 360 degrees. If you total up all of these angles, you get a total of 363.6 degrees. Now, really, it should be 360. And again, we have now compounded the rounding error we made in the relative frequency column by now multiplying it by a number, which literally makes the error more noticeable. So again, do not panic if your number is not exactly 360 degrees. All right, from here, it's time to start making your pie chart. So you begin with a circle. All right, now, if you're going to make one of these by hand, you actually need one of these devices to do with any degree of accuracy, and that's a protractor. And remember, how you use a protractor is you line it up with the center of your circle. You establish a baseline for your angle, so you connect the center of the circle to an outside edge. And then you measure up from that line to the size of the angle you want. So 90 degrees is, of course, straight up. All right, so I draw a line from the center to the outside edge. And now a 90-degree angle, I would go from the center to straight up. Next, you shade in that section of the graph. And then you usually label. Now, you can put a key off to the side, or you can just sort of label right inside of the chart, like this is the associate's degrees, and this represents a portion of the pie that is 25%. Now, a bachelor's degree is supposed to be 50%. So now, using kind of this vertical line as my new starting line, I'm going to open up an angle of 180 degrees. 180 degrees is going to be half a circle. So I'm going to continue here. I'm going to color in my new section, and I will label it. Now, master's degree is supposed to be 21%, and if you're not relying on a protractor, you want to aim to be as accurate as you can. So 21 is going to be most of this last section. This section is 25%, so I'm going to do something like that. I can color in that section. This is master's degrees, which is 21%. And then the final little piece of the pie represents the last category. That's this guy in here. If the slice is too small, then you can do something like this where you draw an arrow to it and you put its appropriate labels outside of the pie. So doctoral, 5%. And then the last thing is the pie chart should have a title. So this would be the types of degrees, and that's conferred in 2018. That took a lot of time to do even without using the protractor to get good accuracy. So we do have technological tools available to us, so we're going to see how to create one of these in Excel. But even though we have computer technology to do these things for us, it is useful and valuable to know how to do one by hand so that when your computer generates a graph for you, you understand what to expect and you'll recognize when there is a problem. Now, the next one we're going to do is called a Pareto chart. Some people say Pareto. And a Pareto chart is very much like a histogram, but it's a special kind of bar graph. Usually there are spaces between the bars in which the height of the bar represents the frequency, and you put the bars in order of decreasing height. So the tallest bar always goes on the left. And again, this works well for qualitative data, data that's in categories like you see here. This is example from your book, but updated with 2019 data. In 2019, the top 5 leading causes of death were, and you can see I've got my data here. I'm going to make a Pareto chart to organize this data. When working with large numbers, just like in the last example, where you saw they reported the data in thousands, that's a good idea to do here as well, because realistically, if I'm graphing by hand 173,040, I can't do that with a high degree of accuracy on a small graph. So I'm going to say, okay, 173,000, I'm going to put a label of thousands on my numbers, and that way I can just focus on graphing the 173 accurately. I've gone ahead and written all of them in that same style. And now for each category, you want to identify your largest frequency and your smallest. This appears to be the maximum. The lowest number on the list looks like 150, and so that's my minimum. And again, that's important to know because in a Pareto chart, you go from the tallest bar down to the shortest. Now, it is really essential to be doing these things on graph paper so that you can be as accurate as you can by hand and you can create a chart that looks decent. On the y-axis of a Pareto chart, you always put the frequencies or relative frequencies if that's what you choose to graph. And in this case, remember these numbers are in thousands. Now, my minimum is 150, my maximum is 659, so I'm going to choose a scale of 100. You kind of have to estimate an appropriate scale for the space you're looking to fill. Your graph should end up taking up most of the space available to you. On the x-axis, you put your categories. And again, we're going to leave spaces between the bars here. So I'm going to go 2 boxes over. I'm going to put down my first little tick mark. And my most frequent cause of death for 2019 was heart disease. So I'm going to center that label on the tick mark. I'm going to estimate where 659 would fall on the y-axis. So, 650 is halfway, just a little nudge higher. And I'm going to put a horizontal line across that goes 1 box to the left of the tick mark and 1 box to the right. Then I'm going to connect that straight down, and I've created my first bar. I'm going to skip a box, go over a box, and again, put a centering tick mark. The next leading cause of death was cancer with 600,000. So I put the label below the tick mark. I figure out where 600 would be, go 1 box to the left and right of the tick mark. It's important for all your bars to be the same width. All right, I'm going to go ahead and finish up adding the other bars. All right, with some apologies for my lame coloring job, it's a little bit hard to color on a writing tablet. Here is my completed chart. So I've got the categories across the bottom. I've got the bars organized from tallest to smallest. They are exactly 1 box apart. And the last thing I would be missing, of course, would be a title for this chart. So we would call it, these were the top 5 leading causes of death for 2019. So again, that's how you construct one by hand. It's not particularly difficult, but we will again look at what technology can do for us.